Hi everyone, thank you so much, and welcome to the channel. I'm Sai, software engineer at Limitly and Xmeta. I would like to walk you through one of the core problems that would happen during caching. Typically, in most of the system design interviews, we tend to use caching as a strategy, and there might be a lot of problems. So when you get deeper into the deep dives, there is this one common question that always comes up, and I was in the same shoes and I struggled to solve that specific issue. So before jumping in, to the exact problem, let's see what this video is actually focusing on. And I have also attached the exact timestamps under the description so you can skip it to any part of the section that you're really interested in. So first, we would see what exactly is the caching, and then we will take Twitter as an example and showcase the usage of this caching and have this would help. And then we would look at the core problem that we are going to focus on today, which is nothing but Cache Stampede. And then we'll focus on what is the solutions that we have, and the most importantly, how should we implement those solutions, because you can come up with some solutions, but the interviewers, based on your level, will be digging deeper on how do you implement that specific solution. So that would be the area that I'm super interested in, and you can always skip to this part. So first of all, let's see what exactly, why do we need a cache? So you have your service in the backend, and which would be getting data from database or the data store, but instead it can also look into cache and it can see if the data exists. If so, it can get data from the cache. But question to ask, why do we need this? Why do we need to get data from cache? Pretty simple. Cache is super fast. How much faster it is? Like cache is like 10,000 times more faster than your SSDs, like hard disks. So reading from cache, it's super easy, and it can also scale up to like 100,000 requests per second. It's pretty easily. So because of these reasons, we tend to get data, and having a cache would always be the best solutions when you want to scale the system. And the next thing, the other point that we need to consider is when we have this 100 million plus users. Let's assume Narendra Modi has 100 million plus users, and I think as of 2025, Narendra Modi do have like 100 million plus users, followers on Twitter. So if all these users would love to fetch the post of Narendra Modi, the most easiest way and the most granted way would be like reading it from the cache, because as you have seen, it's faster and it can also scale for 100,000 requests per second at ease. So because of these two reasons, I think most of the systems would support the caching. And now let's see with an example what what exactly is the problem that interviewer would be interested in, and see how can we resolve that. So let's take this happy path. Let's say you are a user on the mobile device and you have Twitter, and now imagine Twitter at scale is having 100,000 requests per second, and it goes to the newsfeed service to get back the news feeds. And imagine this 100,000 people are following Narendra Modi, or it can be Elon Musk, or it could be Taylor Swift. And let's assume it's looking for a specific post of one of these celebrities. So imagine that's already been cached. It's a happy path. It can get that data and it can return back to the user. Clean, no questions asked. Then what we generally do is like we set time to live on the system, and you can have a question that why is it only like 60 seconds. So you have to be as close as possible to the real user's data, and because if you're following a specific celebrity, you don't want to have that much inconsistency. So to avoid the staleness, let's imagine that we have 60 seconds as a time to live. Now, what happens after 60 seconds is the exact core area that we would be focusing on. Like what happens after 60 seconds? After 60 seconds, the data is unavailable. When these users would be looking for their celebrity posts, the data is unavailable, and all these requests now from the newsfeed service would be heading to the database. So this criteria of thundering all this requests to the database in sudden is what we call it as cache stampede, or it also is also named as thundering herd. And this is the area which I struggled, and probably this information could help to sort of talk during the deep dives. Now, let's see what are the popular solutions do we have, and first thing that I would always consider, it's called request coalescing, and this is a technique which I would prefer to come up with in most of my interviews. So let's go back to the same example. We have this 100,000 requests looking into the cache for this post P123, and it's not available. And what this technique says is that instead of sending all 100,000 requests to the database, you sort of keep 999,000 requests in your server, whatever server, you would sort of hold them, and only one request would be heading to the database, and it would update the cache, and it would return back to the user. And after some timeout, the rest of 99,999 requests will be going to the cache, and since this request already updated the data to the cache, this 99,999 requests should be able to get the data. But the question is not about this. The question is, how do you actually implement that? That's the question. So now if we look into the implementation details, so what the actual solution states that is that, so imagine the 100,000 requests goes to the cache, and it comes back and it says, hey, we are not able to find the data. Then this 100,000 requests will try to do something called row locking. And the beauty of any caching systems like Redis, it will not allow all 100,000 requests mutate the same data at the same time. So it would only allow doing that for one request. So out of this 100,000 request, only one request will be able to lock that specific row for a certain period. You could imagine that it's locking the post P123 for 5 seconds, and the rest 99,000 requests would say, hey, somebody is trying to get the data, so let's go ahead and let's wait in my feed service. Now, how can these requests wait in the feed service? Simple. uh, I'm a regular user of JavaScript. JavaScript has something called timeout. It can use techniques like set timeouts, similar to other languages, and it can wait. So in meantime, that one request goes to the database, it gets back the data, and it would update the cache. That's the magic. And after a few seconds, the timeout would be unlocked, and this all 99,999 requests is released, and it goes to the cache. By the time it had looked at the cache, it has the data, and it can return back to the user. Now, if we, instead of sending and flooding the 99,000 requests or 1,000 requests to the database, we are only sending one request that's filling the cache, and the rest 99,000 requests is actually getting the data, and it's sending back to the user. So that's the beauty of this technique. And second technique, it's called pre-warming hotkeys. Imagine if your hotkey is expiring after 60 seconds, you can have a cron job at 50 seconds, and it can look for the hotkeys and it can sort of pre-fill. So to elaborate this, you have an async job that will look at the cache. It can understand what are the hotkeys that's going to expire in next few seconds. It goes to the database and it can get that data, and it could, like pre-hot the specific cache. So now the question is like, how do you implement this? We can have few easy techniques. So Redis has the built-in mechanism to track the popular keys, and it can fetch, hey, can you give me like top 10,000 keys based on the eviction policies, and Redis supports those operations. And this async surveys that you're actually seeing on the screen, it can sort of fetch that data, fetch those keys from the cache. It can go back to the database, get the data, and warm these caches. So it's pretty straight, pretty nice. And in case if a recruiter have asked, hey, do you know any other techniques? One thing I would say is like, how about building an async cron jobs that would run every single day, and that would configure all the hotkeys that's been hot on the previous day or last 1 hour, and this async service can use that config service and get those hotkeys and probably cache the data for those hotkeys. That could be one solution, but I think this should be good. So if I sort of recap, we have covered what exactly is the cache, why do we need it, and a specific example on when the stampede could happen. And we then jumped into the two solutions of request coalescing and also pre-warming hotkeys. But the most thing that I'm super interested is on, like how do you implement this request coalescing using this row locking, and last but not least, how do you, know the hotkeys and warm them. That's it. Hope this is clear. And please feel free to comment, and I'm more than happy to take a second session of video. And thank you so much for listening.